Good morning, gentlemen. I finished up my day yesterday and I didn't shoot a segment. I figured I'd pick it up first thing this morning. Yeah, we're doing these segments literally in day intervals. This will be day number 6 that I've gotten to work on this box. I was talking with Tony, my friend Tony over at ICA, Fat Boy, and he says, you built this. I told him, I said, I've been on it for 5 straight days now. I took a day off there, but 5 physical days working on this, and he goes, in his heyday, this is what he told me last night, he goes, in his heyday, like, if he could keep everything away from him, and the phone wasn't ringing, and he wasn't having to answer a bunch of other questions, he could do 1 16-pill section a day, and then it usually takes another couple days of futzing around with it to get it done. I said, yeah, well, my goal is to try and have this thing done today. So, okay, so where we left off last night, or where the segment is that you guys left off, I think that the amp was orientated something like this. Let's see. So yesterday I focused on getting the on-off switch and the on-off indicator LED in the front. We got all of the capacitors installed on the positive rail to help throw them out of resonance. We also put a diode up in here, a little 6 amp diode. Look, people, you go out there on Facebook and you do like a survey. Why do we put this diode on there? And you're going to get the answer, well, it helps protect the transistors if you hook the wires up backwards. That is a side function of this. That diode actually helps. If you get down and you measure what you have for signal saturation after it comes off the transistor back to this board, the capacitors do most of the work to try and keep the RF off the positive rail. But that diode is like a clamp. It really, because the RF can pass through the diode and then shun itself to ground, and a lot of people don't think about that. But I got the diodes in. I got all the power wires built, tinned, and installed. And I'm going to leave you this little segment here. Let's just look at how the wires are wrapped. And I've got one half of the amp wrapped one way and the other half of the amp wrapped the other way, and the positive wires, just for fun. Doesn't serve any electrical purpose other than it's just fun. Let's see, we got the output combiner installed, relays permanently mounted down, the input splitter network primary stage 1's installed, the foot pedals installed, the coax connectors installed, the remotes installed. We got our 3 lugs worth of ground distribution installed. Remember, we're talking about 1600 amps is what we've got to provide, enough ground to carry 1600 amps worth of pixie smew into the box. So we have to think, most of this stuff, I've never bothered to look now that this comes up. This was a discussion that was going on in the Patreon group. I believe the question was, what is the pound copper weight of the board? And to be honest with you, I know what they say. They say it's a 10-pound copper board. I've never bothered to Google what that means. All I know is I look at this board and I think that there's less than like a penny and a half worth of copper, pure copper, that's been spread out across this whole thing. So the best way to get current to the situation is multiple cabinet attachments, because this case is going to carry a lot more current in certain situations than the board. But if we spread that 1600 amps out across 3 1.5 inch wide tabs, 1, 2, 3, we're only asking each tab to carry, 550 amps or whatever, right? So, because this guy's not going to run at full tilt, but still, I'd rather have a little bit extra than not enough, and we have a heating issue. I am not a big proponent of ground braid when it comes to cabinet grounds, if you guys didn't know. You'll see that I've used them in the past. I'd rather do this copper, a couple thousandths thick copper, and then not solder it rigid, solder it so it's got like a flex joint here at the case. Braid has got its own electrical resistance properties, and We kind of plated those when we're doing grounding and bonding in the truck, but in this situation, it's just straight current delivery. Just straight current delivery. So I don't want to add that resistor in there unless it's absolutely necessary, but it was all the little details. And then I spent an untold amount of time yesterday making all the new harmonic suppressors. This will work just fine. You guys, everybody knows that this will work just fine, but when there's a problem, the 5 watts work better in every way, shape, and form. Then the big debate. The 5 watt resistors here in the circuit, and here in the circuit, and here in the circuit. According to some, so they don't look cheap, they have debated amongst themselves now for over a decade that the only reason they use 5 watts is to help hide imbalance. I've proven over and over and over on video, once you have an imbalance, you could have a 150 watt resistor in there and it's still going to go up in smoke, right? It is. It is. It absolutely is, right? So I like 5 watters. It was worth it to me. I dug out a bunch of 104s. This is 104s with 100 ohm capacitors and 100 ohm resistors, 104 capacitors, pardon me. Today, my goals are, well, we're going to get the remote wired up. We're going to get the foot pedal wired up. We're going to get our on-off switch up here in the front of the cabinet wired up and the LED light wired up for that. We're going to get the 4 pieces of coax that will go from here up to each one of the stages wired in. As in, like, we're going to make them present. We're not going to hook them up yet. And we're going to do the same thing with the output. We're going to use RG400. And I've got to come up with a creative way to store the coax. But we did mount this up on its side. Like I've stated in multiple segments, why I would like to do that. And here is our output inductor coil. Look at how small that thing is. Right there. And it wouldn't surprise me if I end up having to take a little bit out of that once we go to run it. But the way this is set up now is just temporary, by the way, because I will be disconnecting this. So we'll get there when we get there. Be disconnecting this temporarily, then it's part of the tuning process. And then from there, I got to figure out how to mount this. How do we get the RF out of the box, and how do we meter the RF, right? So they call these a backbreaker. You go talk to the guys and they call this big ass cabinet, because this thing is really quite large, they call it a backbreaker because to them they're always hunched over it, and I'm like, nah, I got Tech 9 technology over here, baby. I felt the lazy Susan. And I've stood in one spot and brought the amp to me and just switched hands or whatever. The first time I seen one of these used, it's like, everybody knows what a lazy Susan is, but I was watching Tech 9 and he had a little amp. I was like, man, I got to get me one of them. So I built me one. So I got to get on the phone with the customer. He's not going to be able to run this. Right? This will hold for a hot minute, a PL259, and I'm not too worried about the pressure here at the input. We don't ever see those really burn up that bad, but the output connector, I mean, I don't know what he's got for coax in his truck right now. I'm going to have that conversation with him here in a minute, but he's going to want to change this connector out. But we'll stick with the PL259 while it's here. Thinking I'm going to have to fab up some kind of bracket and mount this like so. And I got to thinking about it. There's no point in putting a PL259 connector on the cabinet and then having a jumper hoop up, like what I did on my 48 pill, which worked out beautifully, then have the jumper hoop up to the line section, versus let's eliminate that one connector and that one impedance bump. I'll take the coax directly from the relay, come out through like a Heiko strain relief, like somewhere in here, and then bring the coax, like the RG393, bring it out and hoop it over to the line section that'll be permanently affixed to the amplifier, which is where it needs to be. You want to share a common ground between the case of the line section and the case of the amplifier. So the goal is to get this thing ready to operate and be able to do the beginning stages of tuning this thing, and then we're going to check each individual 16 pill section. So let's just get to the point where we can key it up and we can pass RF through it, and I can get our pass-through tune set up, which will be happening today. And I'm going to call the customer. I have never understood why guys do this kind of setup and then they don't reinforce the cabinet or put any kind of gusset that comes off the back of the line section back to the cabinet, and these always get ripped out. They never spend the money to do the porcelain tapered tip that's got threads on it, so you can literally drill it, mount it, bring this through and have a porcelain tip on the inside of this thing, versus they'll just take this connector off and then solder to the center pin, which I'm not a fan of doing that, but this is a coaxial dynamics line section. Or if we change out 4 screws and build a couple brackets, we can hard mount it to the case. There's no pressure on the case. Like, this is a long lever if you think about it, that's substantial in weight, versus just simply having it mounted like so. And then I don't like to sit it down below, I like to sit it up above just a little bit, so you can always reach back and know. I mean, let's face it. We'll say, yeah, here, I flip the amp around. And it's just me. This is my preference. Mine that I've got on my 48 pill, and then the one I had on my 64, and then my dual 32s. When I built my dual 64, I built my line section to hang up just like this. I had it sitting up, not down below the cabinet where I couldn't see it, but sitting up. So when I turned around, all I had to do was look back. I could physically turn around and look back and see which way the elements were pointed, if they were aligned or not. And there was no guesswork when I reached back to change out elements, just by having it poke up like that much. If that makes any sense. Just that little bit of clearance, because once you get down here, you're running blind, right? But if you have it poke up just like so. But I've got to talk that over with the customer this morning, so that's where we're at. I am having actually a good time, believe it or not. I know I've been a little bit grumpy through this whole thing. I've got some serious stuff going on. Today is actually the date of the 1 year of my father passing away, is today. But I'm really enjoying this project, and I really am enjoying the opportunity to get to work on this thing. So don't think that I'm not enjoying this. I've just always steered away from building a 64 pill for anybody in the public, because of course mine was built all differently than this. Mine was so twitchy that I thought, man, I don't ever want to build this for somebody that's going to have it on the other side of the United States. And hopefully we're building this in such a design that is so forgiving that the customer's not going to have any problems. Right. And we'll know when we run it. I already told them I'm going to run this thing for a couple days here and talk on it. So you're going to hear me on the radio quite a bit here lately. You're coming up here in the next couple days, but we'll see. We'll see how this goes. Hopefully it runs very stable and not glitchy. Or maybe it runs glitchy. We'll see. We'll see. It'll show how it goes in testing. Let's get on with it. Enough talk, more do. And good morning again. All right, so I got 5 minutes left, so this segment's got to be less than 5 minutes long. All right, so line section's mounted. I was thinking about doing some 393 BS, like I was talking about. I decided no. I'll give them a standard PL 259. Let me grab this here real quick. Let me get over here into the drawer of holding. Now, you can either use a 7/8 element or 7/8 DIN connector, or you can use an LC connector like this, if you choose. That PL 259, the way you're going to run this with a 2x8 homie, you're fine. But if you decide that you're going to go higher than a PL or higher than a 2x8 for drive, that's entirely on your shoes, by the way. You're going to want to change the connector out there. Fact. Okay, so we got all of the input network done. All of this is done. The coaxes that feed each one of these 4-pill split, or the 4-port splitters, is all run and tacked in and trimmed, and we've got it all supported going down the side of the amp, and we've got it all brought over here to the final combiner, or the primary splitter, final stage splitter or combiner's all in there. The only thing I got to do is get the output capacitance tuned up for it. So we're going to start out with this 200 puff and then probably a variable trombone, but we'll put that in there tomorrow when we're ready to get that far. This thing is done for the day. Got the remote hooked up, got the relay for the fans hooked up, got the relay all wired in and tied in and mounted up, got the on-off switch and all that stuff wired in. So bunch of the little housekeeping stuff that seems to take forever. This is how I like to mount these line sections. Look at this. This makes perfect sense, doesn't it? Nice sweeping bend radius of 393. It's under a foot, so it doesn't really add a lot of capacitance or inductance to the circuit. We don't need to really worry about resonance at this length. And he's got himself a nice mounting point. This is firmly attached to the amplifier. The cabinet will never get bent. It's not going to rip out. I left him plenty of room on the inside of the cabinet, so down the road in the future, if he decides to go to a bigger fitting here, he's got room all the way around it. All the way around it. Now let's talk about this. Let's come over here and let's talk about this here. This is our spare parts storage bin, this right here. I went ahead and I attached the high strand count silver plated Teflon high temp wire. So if you do choose to change out this connector, you will have extra wire to go from the connector down to the relay. I gave you a couple extra 100 ohmer 5 waters and a whole bunch of extra 10 ohmers just in case. Just in case. That way all your parts can match in the future if you do have a problem. So tomorrow's going to be a big deal. What I spend the rest of my day doing today is this is where I get out the air compressor and I sit here and I blow out every single pocket, and then I go around with a dental pick and I pick out every single little joint, crevice, crack, pill strip, notch thing that I can get the dental pick in, and I've got to do that 64 times and blow it out, because all it takes is one little piece of solder and the whole damn box doesn't want to run right. So we'll blow that out. That's the reason I got elements inside the line section, because I don't want there to be a chance of anything to fall down inside of here. Period. Okay? So that's where we're at. That's what I'm going to go do. We are 99% done. Now we got to do tuning and final output capacitance. And then we're going to put this son-of-a-bitch on the air. So we'll be back. I got to make one more part. I'm going to throw a little bit of old school up inside this girl. I really am. So the inherent nature of this situation is that we have all of these strands of wire that we have to bring together coming out of the box, back of the cabinet, right? Well, what most guys will do is they'll take this 4 and this 4, and they're gonna hook them together with twist lock welding leads, and this 4 and this 4. Okay? We have to protect against that as builders inside the amp, right? So what I wanted to do from the beginning, and this is one of the major issues I had with the 48 pill, is there was nothing tying the internal bus bars together whatsoever. Well, I left just a little bit of room at each one of the ends of the bus bar so I could sneak down in here one 12-volt lead to tie to each one of these. And I thought, do I want to make it out of big ornate copper and do some big tricky bus bar shit that most likely will break off in shipping? Or do I want to go back old school? And I feel the old school pulling me in. I really do. I can hear it calling to me, PDI, old school. So we're going to build ourselves an old school internal distribution bus, because we don't have to worry about it actually doing anything for us until somebody makes a mistake. If you go to run this amp, and we'll say these 8 power leads somehow just become disconnected, you're going to create immediately an internal imbalance in the box, because these 32 transistors are not going to have the power of these 32 transistors. And you're going to key it multiple times and half the box will be physically off, right? Where if we add a bar that goes in between each one of the sections, the 1 in a million chance, because I have seen it happen. Had a friend of mine put a couple pieces of 8 gauge in his Texas Star Sweet 16 of all things. He had one piece of 8 gauge running 2 of the pallets, so 4 of the transistors, another piece of 8 gauge running the other 4 transistors. And down in his sleeper, where he couldn't see it and he didn't know it, the set screws for one of the 8 gauge connectors backed off, and he only ran half the amp and burned the whole box up. That's one of about 700 instances I've seen like that, where I pour a ton of energy and effort into something, and then as soon as it gets out of here, situation outside of somebody else's control, right? 1600 amps is going to move around inside this cabinet. I've got to create basically an 800 amp fuse. Okay, it's all lined up the way I want it, I guess. Hold on. There we go. You'd be shocked how much current can go through that. You'd just be shocked. I know I was when I started measuring this stuff. Remember, this is a just in case thing. This isn't life or death. There's really no load that's presented here, unless somebody's stupid. Nope. Not enough flux. All right, let's try this again. We straighten it back out. Let it cool down for a second. We'll scrape our dross off. Last one. Jab it. Okay, here we go. Take up here for some reason again. Quickly flatten it out. Okay, now we've got to wait for a couple hours, let everything cool off, right? Audio. Okay, so we have an imbalance. This output combiner resistor is getting hot as nikes. This side of the resistor is getting hotter. So it tells me the problem is here. Then we go and we look, we see that this flyback is getting hot. So right here, and this transistor is trying to work. This one is not, this one's working, this one's working, this one's working, but that one's not. If you notice, change your perspective here real quick. If you notice, there's two black dots. There's one on each lid. And the reason I had to put a black dot on this one and this one, because these are transistors that the lids have come off on. Either being transport or when we took the amp apart. And that tells me that this one transistor is bad. So this is part of the fleshing out process of this thing. I'm going to have more as I go. I can almost guarantee you. This row is probably safe. This row in the disassembly process and on indoor transport had this cap off and this cap that had come off. And then this end row is the one that's really super sketch. This is the one that had all the caps that come off when it came in here, in the 48 pill section, which is from here down. This section's lighting, no problem. This one's lighting. I mean, I'm putting 80 watts in it and I'm getting over 1,000 out of it right now, but this section's dead. So that means I got to go in here and pull this end transistor out. Yeah. So I'm going to have to, it's simple. I figure out the tune for this one and then I'm going to have to test each one of these stages individually, I guess. We'll see. I mean, to give a shameless plug to the steaming coax digital meter, not even shameless. So we got our 1,000 watt in peak in 1X, 1,000 in peak, 5 watt slug in reverse back from the Bird 10,000 watt dummy load. Hello, 1, 2, 1, 2, 1, 2. So we're putting 126 watts, 126.3 watts. Let's zoom in on this so you guys can take in the full beauty of this thing. Hello, 125.6 watts. We're putting into this box. Hello, 1,400 in peak. And that's just on this first 6 pill section with only 125 watts of drive. Pardon me, 16 pill, not 6 pill, 16 pill section. The idea, the theory is that I can fletch out all the problems here. I can get the input tune figured out. And by the way, the input tune on this thing is scary good. For being that this is built from 2 separate amplifiers. Well, 1 separate amplifier and then added onto it. Hello, 1, 2, 1, 2, 1, 2, 1, 2. Hello, 1, 2, 1, 2. Get it all the way back down to 0. The moral of the story is it's swinging backwards and collapsing at once more drive. So in turn, all this is really sharing with me is that this section is completely tunable, and when I go to put everything together in its final put together kind of thing, I'll be able to adjust here perfectly and all the other input stages exactly the same, and allows me to tune each stage exactly the same. That's a lot more trombones, but a lot of guys would use fixed valued caps. I want to dial everything in perfectly and balanced as best as I can get it. We're going to leave our shorting armatures unsoldered over here on the input and also over here on the output, because we're going to have to adjust those a little bit when we go up and drive. As our voltage increases, aka our watts output, the output of each section increases, the inductor in the pi, this is a pi circuit. So we have our combiner, then we have our inductor, and then our capacitor to match to the load, right? The same thing on the input. We have our input 50 ohm piece of coax here. So then we've got to balance this to the load, which is the radio, our coil for frequency, and then our splitter to each one of our ports, but each one of the 4 ports is a balanced 50 ohm load. If we didn't have a balanced 50 ohm load, we'd have to add yet another capacitor to help it couple for the right capacitance level going to each That makes sense? So you have a pi, which is a capacitor and an inductor for frequency, and then a known load value. And if you want to do like a pi L, then you'd have a capacitor, an inductor, and then another capacitor. Simple, right? Monumentally hard, but simple. But not so hard, but simple. But hard for some, but yeah. Okay, so section number 2 here is all hooked up. We're looking at the steam and coax meter and peak, and my bird meter and peak. Hello, 18 and some change, right? Got our amp draw. Hello, 1, 2, 1, 2. So this section's running just like a Swiss watch. Let's go up here. Let's take a look at our input. Hello, 1, 1, 1, 1, 1, 1. Just like the previous section. So that tells me that this section's good. None of the transistors are bad on this section. I've got 1, 2 Sharpie dots on this next section. And these are all old section parts, this one and this one. So we'll see. We'll go ahead and we'll transfer everything over. And I'm using all the stock coaxes, right? So I got to thinking about it. It's not smart to not use this coax here and use these coaxes on the output, right? Yeah, I've got to run with what's in here, that way I can make sure everything's right. So by running the stock coax and taking it off the combiner back here and moving it over to the relay, I can now check the coax running all the way to here and here and here, and then vice versa, from there back to the combiner, from there back to the combiner. So the only thing that I'll have to mess around with once I get this all 4 of these sections running is the tune here and the tune here. That makes sense? So we've got 32 transistors checked and a rough tune applied to both of these sections. They tuned out exactly the same, which is awesome because now I know where to go for here, and we'll overcome whatever parts we have that are not right here in this section, because there's something. This one I had to go in and I had to pick, and I ended up finding a piece of solder that was shorting out this 4-pill section that was the size of a pepper flake, right? So that's even after us washing it last night, blowing it out with an air compressor, blowing it out with an air compressor again today. There still was just a little piece of shit in there, and I flicked it out and the whole section come back to working. So let's go ahead, let's move over. Let's get this one, and then I guarantee you this is gonna be our problem child, and that's the reason I put it down on the end, so I could get to it easy. I've never mentioned this on video before, but the lids you've got to hold down with this special kind of epoxy. It's made for ceramic. Don't use super glue, although when you burn it, it does kind of smell like super glue. It's called PST 12,000 jade epoxy, and it's made for doing ceramic to ceramic, right? You can find it in some hobby shops. I ended up ordering mine off the internet, but then you get a bunch of the little tiny filler tips. You just go down and just very lightly put. The reason that's important is we're living in the land where these transistors are incredibly expensive, right? So this lid came off in disassembly. And let's see, there's another one in here. This one down here also came loose. Well, as soon as I saw the cap was loose, I went in and put just a little bit of epoxy around it, because that's the only thing that holds these caps on is epoxy. It's not a vacuum seal, by the way. And put a little bit of epoxy and apply pressure, and then let it sit in the epoxy cure. And I just saved this guy 2 new transistors at the cost of $250, or 2 used transistors at the cost of $150. So I saved him $500, or I saved him $300, however you want to look at it. But this section here tuned out just like the other 2. 1, 1, 1, 1, 1, same amount of drive. Hello, 1, 2, audio. 790, 787, somewhere in there. Perfect. I mean, perfect. Oh, yeah, input tune here. Let me show you. Not that it really matters, because, well, it's going to all change anyhow, but. Hello, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Perfect. Sweet. I might actually get to be able to talk on this thing today. Probably tomorrow, because I got to go through the driver yet, but bank number 3 completed. Also, over on the input splitter, I've marked out which port is what, and then over here on the inside wall, I've got bank 1, bank 2, bank 3, and bank 4. I've got them labeled. And I'm doing that because this amp's got to go to the other side of the country, and if there's a problem with it, we can't realistically be affording to be able to send it back and forth across the United States, right? It's just not. So I have to embrace the fact that somebody else might actually put their fingers in here. So me, am trying to give them a path to success for in the future, right? So somebody else comes in here along behind me, they can go and trace, okay, so this piece of coax here goes to port 3, and then as a guide in reverse on the output side, I labeled each one of the ports 1, 2, 3, and 4, and then over here on the combiner 1, 2, 3, and 4, and they're all wired the same. So that way you don't have to physically try and trace any wires. Just trying to plan into the future. Let's get section 4 up and running, and I want to be done. Wow, this guy got lucky. That's all I gotta say. Okay, so last 16 hooked up, we flipped the amp around. Remember, both 1000 watt elements. That's in 2X. That's in the face valve. I'm telling you, this thing has made it slick. It's so easy to, get a couple more of them, like 6 more probably from my own station. Okay, here. Hello. 1, 2, 1, 2. It's working just a little bit better than all the other stations segments. So that could be from false input or false output, because I do have a wire extension that's going from this lead of coax here over to the relay, and then vice versa. I've got one here going to there. So if I go up here, let's crop this around so you guys can see it. Grab the microphone again. I'm gonna need a screwdriver. If I go in here, I want to show you something. Check this out. Input swears. Hello, 1, 2, 1, 2, 1, 2. Now watch this. I'll come in here and I'll put a little pressure on this. Hello, 1, 2, 1, 2. Like I said, it can be a little bit of false indicator. So what this section taught me, and this is something I was planning on doing anyhow, is the tuning tubes and this board always have to keep into mind that this electrical potential, probably zoom out some more, this electrical potential is different than this electrical potential as far as the RF is concerned, because there's such a huge distance. So like, as far as the RF is concerned, it's got to go down through the case, back up through the screw, and then over to the transistors or over to someplace on the board. Because of that gap distance, and then how I've got it bolted here and here and here and here and here and here. If I simply take a screwdriver and push down on this tube, like so it makes contact with the case, input reflect drops to 0. That's telling me there's not enough, but that's why I put this on flexible, little piece of like 12 gauge or whatever. I can just go down here and throw a solder tack on this tube. Well, no, I don't want to do that. I better put a piece of wire. Let me solder some wire on the bottom of all 4 of these tubes so it can flex. The front can flex and the tube can move, and if I solder that solid within a year, that'll be broken, especially in somebody's truck. Okay, so now what I got to do is disconnect all this temporary stuff, get it all locked down, and then we're going to leave all of these tuning armatures. We're going to leave these free floating, this one, this one, this one, and this one, because I might need to adjust the capacitance just a little bit after we get this portion of the circuit put in. But there were no blown pills in this section, and I've got 1, 2, 3, 4 caps that were loose on this section. So by having the knowledge of the glue and having the knowledge of how to handle it, I might have just saved this guy almost $1,000. And the other thing that I'm really tickled about is they all tuned out exactly the same. So What I mean by that is the inductors are all the same, the capacitors are all the same, and I didn't have to modify any of the capacitors. They're all adjusted to the same depth, input and output. That's math, baby. That's math, baby. So I had a problem happen here. Went to go tune this thing out, and I finally got it up to where I was ready to jump over to a 25 kW slug, specifically this 25 kW slug. And I haven't used this thing for probably 2 years. This one here. Haven't used it for quite some time. I go to put it in a hole, and it don't do nothing. Don't do squat. So that's got to go back to coaxial dynamics, and they're going to have to figure out what's wrong with it, because I have a policy about not taking apart my elements for nothing. There's a reason that I have sponsorship from these guys. So might as well just put it in a box and send it away, right? Okay, two things. I want to give a big shout out to the Patreons, these guys down here. Thank you for helping support the channel, all of you guys out there. All 900 and some of you at this point. Thank you, gentlemen. Apple has started some new thing where they're going to tack on a 30% usage fee because, well, you know, Apple and greed and corporate America and reasons and stuff. So if you are a Patreon supporter and you are using the Apple software through the Apple Store, I don't even know what to say other than damn Apple is what it is. But thank you to the Patreon supporters to make it possible for me to take 2 weeks out of my life to be working on this thing. And thank you to the gentleman that sent up the project here, but I'm really ready to be done with this thing. Had a couple different failures as we went. First, this was my tuning tube here. I lashed two of these things together to be able to get the right amount of capacitance that I wanted to be able to have. And this worked fine until I got to about 8,000 watts. And when I got to about 8,000 watts, it started blowing plasma out of the back end of the tube. It was arcing, so now I had to go and redesign. Pulled the tube out, put a vacuum variable in here to be able to hold the kV. We added the doorknob over there by the relay. The doorknob is 50 picofarad, and the vacuum variable is, I think, 25 through 100. This guy here. So, and I spent a couple days just messing with it, playing with the tune on it. Yeah. Thing runs just as I expected it would. Maxed out, this box should make about 16,500 to 17,000 watts. We're not going to see that today because we're not going to max it out. The gentleman's going to run this with a 2x8, which will get us in the order of somewhere between 12 and 12,500. Let's see. I put the fan kit together for the thing. Now, you know, I'll cover that after we show the test on this. So, simple peasy easy. First, we'll turn off the 64 pill. We'll turn the driver on. But 1, 2, 1, 2, 1, 2, 1, 2. Not 2,000 watts worth of drive. So we're maxed out going in. Now, I get to use these on camera for the first time. My friend Brent over there, wrong way 209. He's out of the Northwest. He wants me to start using his little pointer sticks. He sent me over some pointer sticks, and I think they're pretty freaking neat. This here is a 10,000 watt element. Nope, I just lied to you. Totally just lied to you. That's a 5,000 watt element. So let's go here, press this button down. So this is a 5K element that's in here, in this one here. And this is a 10,000 watt element, and we've got it in 2X. So when the needle gets directly between the 40 and the 50 mark, that's 10,000 watts, and then every major hash mark after that's an additional 2,000 watts of power. So how that works out. I know it's a little confusing, but I'm sorry, the 25 kW Slavic is broken. First element I've ever had fail, by the way, from coaxial dynamics. So right here between the 40 and the 50 is 10, 60 is 12. Okay, that next big hash mark there is 14. Then over here is 16, 18, and then 20,000 watts. So that's where we're at with that. This meter will eventually read over here, the steaming coax meter will read, I think, OF for overload, or OL, I think. It's going to read overload because we're going to go blowing by its ability to read to 10,000 watts. This little hash mark here in the middle, right there, is 5,000. And when it reaches over here on the end, then it go ahead and it's time for you to change it to another element anyhow. So this one allows us to read 2x. This is also in 2x. So with a couple thousand watts of drive here, 111, hello, 111, okay, 1,800 watts worth of drive. Hello. In the overload section, we're making 12,000-ish watts. No pain, no strain, no fuss, no muss. And it just consistently sits there. And that's just simply because of the drive level that we got going on. If he wanted to put like a 2x8 in it, he'd probably get another couple thousand watts out of it. I don't think it's necessary that in the electrical system that this thing is going to be plugged into. It's about as much as we're going to be able to run this amp. So 12,000 watts, no problem. The pass-through tune on this thing is perfect and spot on. Okay, so let's go over here and let's look at input reflect real quick. This is a 50 watt slug in reverse. Hello, 11111. Hello, 1111111111111. Pretty straightforward. So we're seeing on the 50 scale, seeing about 5 watts worth of reflect with about 1,800 going in. You start to turn up the drive though, that reflect goes up a little bit more. You have to keep things in perspective. Let me explain to you perspective. This is a 64 pill transistored amplifier that produces up, or could produce up to 16,000 plus watts. 5 watts in reflect is a 1.02. 5 watts of input reflect, 5 to 10 watts is like a 1.03, 1.05. With 2,000 going in. We got to keep that in perspective. That's pretty gosh darn low for what we got going on. Now, the results are going to vary because this gentleman is going to go and he's going to put this in his vehicle and it's going to have different grounds and the coax links are going to be a little bit different and there's going to be some other differences. Even if you had 100 watts worth of reflect between your driver and your 64 pill, that's still a 1.2. I think it's like a 1.18. I'd have to do the exact math, but it's still an awfully good input match, right? Just keeping things in perspective. But this thing just strokes right along. We're running my bench 2950, 1111111. Hello, 111. We're on 15 volts right now. Makes about 30 watts worth of power. Hello, 1111111. Dude, I'm telling you guys, this meter is kick-ass. He's got a new firmware that's out there that I got to load onto this thing and beat up a little bit. I just need to get this off the bench so I can play with that. And then I've got another battery that I want to hook up to this. XS just sent me the coolest battery. I can't wait to play with it. So, but hello, 1111. Oh, let's turn the driver on. Hello, 111. Hello, 11111. Hello, 1111. I'm pretty pleased with how this turned out. Me personally, I'm happy with it. So let me shut down the big 2,500 amp power supply. This thing is not starving for juice at all. Under load, After we make it through all our connections and stuff, we're pulling down to 14.9 internally on this. And that's measuring it at the fuse. And I'm jokingly referring to this as a fuse, by the way. Let's talk about the fans for a second. So you remember how there was voltage regulators on the fans in part 1? And I said that that had to be completely addressed. Well, I thought I could get away with it. I put the fans on this thing, on this cabinetto here. And I put a bunch of chokes and the resistors, and then I put on here, because I wanted to, these metal guards to keep shit from getting dropped in the box, number 1, but number 2, to try and help just a little bit screen the RF out of the fans. Look at where they sit. Directly over the energy source, right? So I put the fans in here, and I go and I start running it, and the fans will stay running, and I go, hello, audio, and then when I come back down to a dead key, the fans will go, poof. So I'm going to try this. My first time ever using one of these. This is an 8 through 62 volt input, 13.8 volt regulated output, 10 amp regulator. It's potted, it's got its own heat sink. There's no kludged together parts hanging off the bottom of the fan. Oh yeah, my finger looks great, doesn't it? Sure feels wonderful, I'm here to tell you. There's no kludgy parts. So I just got this in today. This has actually delayed the wrap-up portion of this video by a couple days because I want to have everything working perfect. I'm going to go ahead, we're going to slap this on the amp. We're going to weasel this down through over to the fan relay, and we're going to see if the fans stay running. That's our big experiment here today. The amp that never wants to get done. Okay, so I put the lid on, fired down, and the fans ran flawlessly for the first 2 keys. And then they completely quit. He gave me the big giant middle finger and said I'm number 1 in its book. And so I thought, great, I just smoked all 4 of the fans. And if you know how that works, that math adds pretty quick. I'm already like 7 days over budget on this deal. And it's so stupid that I'm even talking about, oh, let's build a 64 pill in less than a week. I pulled the lid off and I hooked the fans up to power, and the fans turned right on. They said, hey, no problem. I start looking at my 10 amp DC relay back here. I've got sitting here for fan use. That sure looks like the contacts inside that relay are smoked. I mean, look at this. Inside of the case is black and everything. So I must have enough choking on the fans. I don't have enough choking here feeding the relay, and RF's getting in there. I mean, I can't see how 2 or 4 half amp fans putting a total of 2 amps worth of load. Yeah, I don't see how that could spike up and cause this to burn up. Probably have to replace the relay. Let me tinker with this. We're almost done, you guys. We're almost at the end of this song and dance, I swear. This is a 10 amp 12 volt relay. And I have both sides of it pinned together. And it's still see if I can get done with this project and not put one more hole in this hand. I've got a hole here in my palm. I've squished and mashed my fingers. I mean, it just destroyed this thing. So we went the other direction with it. We took a 10 amp, or pardon me, 25 amp, no, 30 amp. It's 40, 30, 10 volt D. This is an automotive 25 amp relay. That's what I put in there to replace this one. I put a couple 0.001 disc capacitors on the positive feeding the relay. I did measure it. We were pulling 1.25 amps. 1.25 amps. So it's, I don't know. I think the RF just got in this, and it just wasn't quite. Didn't have enough scooch and the pooch and the shoot to get the job done. But at the end of the day, we go over here. 1 2 1 2. Okay. 1 2 1 2 1 2 1 2 1 2. Hello, 1 2. Over 10,000 watts consistently. Fans are running, parts are staying cool. I'm happy. Everything's in balance, nothing's burning up. Hello, 1 2 1 2. Hello, 1 1 1. Hello. Actually doing like 12,400 and some watts. I mean, it's, you get to looking at this meter really close and you'll see it's scooching past that 60 mark. Hello. Hello. 1 2. Hello. It's getting up there. Like I said, the guy wants more out of it. You can put a little bit more drive in it. The fans are fully voltage regulated at this point. I kind of dig this little thing. My friend Zane at Big Rig Radio says, dude, I was talking to him about how I'm going to have to voltage regulate the fans. He goes, dude, quit messing around with that shit. Just get yourself a voltage regulator off of Amazon. You can have it in a day or so. Ended up ordering one and paid to specially have this thing delivered by like, oh, crack 30 in the morning. This is a 12 volt. It's a little bit different. It's a little bit smaller than the one that was in there. This is input 17 through 65 volt, 12 volt, 10 amp out. Well, coming to find out, it won't put out 12 volts unless you're at a minimum of 17. So ended up ordering this one here, which is 8 volt. 8 through 65 volt, 13.8 volts out. And I thought, well, man, that'll sure help the fans turn a little bit faster. I've done every trick on the face of the sun to try and keep the RF out of the fans. I had one amp that I rebuilt. It was kind of big like this. And I must have murdered a dozen fans trying to get them to be happy. RF would get in them, I got the grounds lifted on these. I've got every trick in the book that have been done to these fans to keep them safe. So if a little friggin' $3 or $4 relay burns up, oh well. I've had coax. I had the little piece of coax. I had one piece of 316 coax. Here it is. No. I had a piece of 316 coax that was in here that I put in here. I cut it, and I spent half a day trying to figure out why I wasn't getting any signal to this one section. It seemed like half a day. It was like maybe 30 minutes. Friggin' piece of coax was bad. I've had all kinds of rando stuff go on. I've had a couple of the 270 picofarad caps that were 270 when I put them in the box. When I go to run the damn thing, they would drop and they were down, like 200. That caused an imbalance in one section. But all in all, to graft a 48 pill built by somebody else, put it together with today's parts, and somehow manage to get everything to shake hands and be happy and be in balance. Man, I call that a win. I call this whole project a win. I know this guy's going to come pick this up. He's probably going to want to run it. I don't know what he's going to want to do. But I'm done. The only thing I got left to do now is to put the sticker on the front, put the vinyl on the front, put the stickers on the back, put the screws in it. But before I put this thing completely away, I got to go inside, lock down all them freaking trombone tubes that are on the inside. I mean, that really worked out slick. I got to give credit where credit's due. The boys over at Fat Boy, that was a design they'd come up with. I kind of copied the layout and it worked perfectly. This thing pulls about 1200 amps to 1300 amps on the peak in its current configuration, plus the 230 amps the 2x8 draws. It's right at max what this guy's got for an electrical system. And I hope This new battery that I'm gonna take a look at next, is probably gonna be one of the next YouTube videos that come out after this, is gonna help fix a lot of the problems that we're having with the LTO community and how to wire them in and install them. You'll see. Gentlemen, I'm done. I'm gonna call this a win. Now what I gotta do is tomorrow I'm gonna hook this up and I'm gonna spend at least an hour talking on this thing tomorrow. Then I can get this off my workbench and I can go do other things. So on that note, I appreciate you guys tuning in. It's been a long hoe for a big old girl. I mean, she's thick. You know what I'm saying? She's got all the curves in the right places. Case isn't all hashed or bent up. Everything in here is new, tested, certified, ready to rock and roll. Now, what can this box do maxed out? We'll leave that up to the owner of the box to play with and figure out. But my portion of this song and dance is over. Gentlemen, my name is BBI. I say thank you to every single one of you guys for tuning in, following along, being here with me, giving me a thumbs up, leaving a comment, support me on Patreon, following along on Facebook. I just appreciate you guys all being here. I am thoroughly one of the luckiest men in the world to be able to have this as my job. And I don't ever take what I do here working with all of you for granted, ever, ever. And I say thank you. Click, bang, boom, whatever, quack, bang, whatever you want to say. By the way, Fat Electrician, dope. That guy is dope. I say thanks, gentlemen. I'll see ya. Bye.